Thank you for watching my video. My name is Mr. Charles Wenike. In this video tutorial, we are still on active components. So in this second tutorial, we will discuss on active component in semiconductors. And under it, we will also discuss active component in current control device and the voltage control device. We will also use some component as an example to explain how active components function in our various electronic devices. Thank you once again. Before we proceed on this video, please, I would like to say, if you like my video, subscribe to my channel, comment, and like. Active component in semiconductors. The majority of electronic devices are semiconductors, the most common of which is a transistor integrated circuit. That is, in terms of active component, the most common types of it is semiconductor, as in terms of semiconductor is called transistor and integrated circuit. That is one or two examples. And then there are also other active components which I have not mentioned too. A basic transistor is generally used in an amplifier which increases the device current input output signal using a direct current, that is DC current, power supply to provide the necessary power. What I'm trying to explain here is the basic, what I have just said before. If you see what I have just mentioned, I said the most common, which is a transistor or integrated circuit, being IC, and in this area I said a basic transistor is generally used in an amplifier. What does it do in that amplifier? It increases the active input and output using DC current, being direct current power supply, to provide the necessary power in the circuit. That is just the how the transistor function in circuit in terms of active components. All active devices control the flow of electrons through them. What do you understand? I say all active devices control the flow of electrons through them. Now, some active devices allow voltage to control the current, while other active devices allow another current to do the job. What I mean is that there are some components that is called voltage control device and current control device. That is why I say all active devices control the flow of electron through them, which means that there are components which is said to be voltage control device and current control device. Voltage control devices. Devices using static voltage as a controlling signal are called voltage control devices. And what are the examples? Voltage control devices such as vacuum tube control their own signal. That is one of the examples of voltage control device, is called vacuum tube. Vacuum tube is one of the voltage device control in active component. Now, what do you understand by devices using a static? You know, a voltage is different from current. Voltage is a static. It's always there waiting for current to come. And once current comes, voltage will push current. So in that case, it means that voltage can move without current. But in terms of current, current cannot move without voltage. So in this case, a voltage control device, the example is called vacuum tube, which control their own signal. Current control devices. Devices working in the principle of one controlling another are known as current control device. Now, what do you mean? What are the examples of current control device? The examples of current control devices are what? Transistors are made as either voltage control device or current control device. Transistor is not just only on voltage or current. Transistor is based on the two sides. It could be current control device or voltage control device. That is the example of current control device. I use transistor. Transistor is current control device and voltage control device. Example of transistor that uses current control device, if I'm not mistaken, it should be a bipolar transistor, which uses current control device. Though when I will discuss on transistor in details, I will explain it much more better. All active components require a source of energy. All active components require a source of energy, which generally comes from a DC component. And you know the abbreviation of DC is direct current. All active components required a source of energy, which generally comes from a DC circuit. In addition, an active devices can generally infuse power into a circuit such as a transistor, triode vacuum tube, or tuner diode. Triode vacuum tube or tuner diode. What do you understand by this? I repeat, all active components require a source of energy. Active device require a source of energy, while in passive device, it does not require a source of energy, which generally comes from a DC current, being it comes from direct current. In addition, an active device can generally infuse power into a circuit, such as a transistor can do that. Transistor can infuse power into a circuit. In that also transistor, you can also use a tradiode, tradiode vacuum tube or tuner diode in terms of doing that. Triode vacuum or tuner diode. This triode vacuum or tuner diode, you can also use them. What they do is they infuse power into a circuit. Transistor can do that, triode can do that, tuner diode can also do that. Those are the examples of the active component that infuse power into a circuit, into DC circuit. Now let me use this little one as an explanation to explain how active components function in our devices. Function in our devices, for example, or for instance, in our laptop, in our television, in our handsets, in our various electronic devices we use in our home or in our offices as well. I want to use this to explain it how it functions. Explanation of active devices. Active components, these are the component that keeps your computer off when you turn it off, and then turn it on when you turn it on. How do you understand by what do you understand by that? What I'm trying to explain here is this. Active device, it will keep your laptop, desktop, any kind of electronics that you are using, handset, anything at all, it will keep it off when you turn it off. It will also keep it on when you turn it on. And when it will do that, it means that there is a certain condition. They also turn on various parts of a electronic device when a certain condition are met. Get this, get this right well. The active device also turn on your electronics, turn on various parts of your electronic when a certain condition have met. Before before this will turn off as well as on, it means that there is a certain condition that both the active and the passive will meet. The condition will meet before it will turn on or turn off. That is what I'm trying to explain here. So in that case now, I will use one another example again. Let's say, for example, when your computer is accessing the hard drive, it is an active component that tells the hard drive LED, as light emitting diode indicator, to turn on to let you know what your computer is doing. What I'm trying to explain here, if you are to access, for instance, before your laptop will boot on, there is a communication in between the active and passive. You know, as a laptop that will boot on, without a hard drive, there will be no, that particular window will not boot completely if your hard drive have an issue, or if the active or passive component, mostly active component, it has an issue. It means that that hard drive will not boot completely. So that is what I'm trying to explain here. It is an active component that tell us that tells the hard drive, that is, the active component will tell the hard drive LED indicator to turn on to let you know what your computer is doing. That is how it functions. Now, in terms of short explanation, it means that without active component in your motherboard or in your electronic device, it means that your electronic device is incomplete and it will not function accurately the way it's supposed to function. Which means that if there is no active device, it means that your hard drive will not, you will not see what your hard drive is doing. That is just a simple explanation. Another significant passive device are inductor and capacitor, which stores energy supplied by active. You see that after, when the active have infused a current into the circuit, another significant passive devices that store the energies, which is there, is inductor and capacitor. What they do is to store it when the active have infused, have generated, or have given out the current into the circuit. What they do is they store it. This one store it in terms of magnetic field, while being inductor, while capacitor store it in another different form. Now, if an inductor and capacitor is not placed in a circuit, the energy flowing from active source will continue to flow and will cause and will case to flow only when the devices switch off. It means it will continue to flow only when the device switches to off state. You get that? It means that if the inductor and the capacitor is not placed there, the energy that the active component has introduced or has infused into the circuit will be flowing until when the system or when the electronic device has been switched off. That is when it will stop flowing. That is just a simple to that is when it will stop flowing. So in that case, it means that both the active and the passive component, they work hand in hand. Because from my understanding, I understand that the active component is useless without passive component. And the same thing is applicable. Passive component is useless without active component. So in that case, thus, energy will not be stored anywhere in the circuit. Did you hear that? As long as the inductor and the capacitor is not there, the energy will not be stored in the circuit. And such a process is totally futile. And futile, it means that it's useless. It means that action taken is useless. It means that in that circuit, the energy will not be stored. And it simply means that that circuit is the useless circuit. The action taken for an active component to infuse a current into the circuit without inductor or without a passive component in there that will store the current, it means that that particular action is infused, is a futile, being useless action. If we cannot use the energy store during the inactive state of the device of the voltage source, it's just very simple. In all, what I'm trying to explain here is such a process is totally futile if we cannot use the stored energy during the inactive state of the voltage stored. It's useless. It's as simple as that. Because the circuit will not work, nothing will work. You remember I used battery as an example to explain or to give you an example that battery itself is an example of active component, which after charging the battery, once the battery reach 100% and you remove it, the battery will be giving out its energy to the circuit. The battery will give energy to the circuit. It undergoes a lot of chemical processes. I will also give you an example of the battery once the time comes. Thank you once again for watching my video. If you don't understand the explanation once, watch the video twice, you will understand what I am trying to explain. Thank you once again for watching my video. Expect more video from me. See you in the next class. Thank you.